Alright, ladies and gentlemen, this is going to be our next video on membranes and specifically going over tonicity types in solution. Let's get started on this next video. So remember, the rule for osmosis is water is always going to move wherever there is more solutes. Wherever there's more sugar or salt in solution, the water is going to move that way. The other way to remember this is salt sucks. It's going to go through and pull that water to the side with more salt, sugar, or solute. Now there's another way that we can go through and think about this because we're thinking about it in terms of diffusion and osmosis. So if this jar is completely full with water and salt, it's completely compacted in there, 95% is water, 5% is salt. In this jar, if I have 8% salt, well, I only have room for 92% water because that glass can only hold the same amount as the glass to the left in the volume in comparison. So there's less water to the right, but there's also more salt because of the space and the volume relationship that we're looking at. So where does the water go? Well, it's going to want to diffuse and move to the area where there's going to be less water and more salt in this particular instance. It's the other way that we can go through and think about it. Now, the question that we have to go through and think about is when we go through and talk about cells in solution, this is what we're talking about when we're talking about tonicity. What is going to happen when I have a fresh glass of water and I stick a salty cell in that fresh glass of water? Where does the water go? Well, there's lots of salt inside the cell, and a freshwater glass has very limited amounts of salt in it. So the cell is more salty than the surrounding environment. And the water is therefore going to move into the cell because there's more salt into the cell. I can say the contrary when I take a really heavily salted glass of water that has a higher salt concentration than the actual salt within the cell. If there is more salt in the glass than there is inside the cell, well, where's the water going to move? Well, it's going to go through and move outside of the cell because there's more salt in that solution. So when we're talking about these relationships, we're talking about tonicity. This is the ability of a surrounding solution to cause a cell to gain or lose water. And it's the relationship between the salt solution in the glass as compared to the salt solution in the cell. There's three vocab words that you're going to have to go through and talk about. And they're talking about the solution in the glass. Hypertonic, hypotonic, and isotonic. These are the solutions in the glass that we're going through and looking at in comparison to the solution in the cell. Let's go through and look at these three vocab words and these three scenarios to understand this in more detail. So a hypertonic solution is a solution that has more solutes. It is hyper, if you're hyperactive, you have lots of energy, and it has more solutes than the actual salt inside the cell. So we're putting a cell in a really salty solution. So what's going to happen? Well, if there's more salt in the glass than there is in the cell's going to lose water and the cell's going to go through and shrivel up. In a hypotonic solution, it's the opposite. We're talking about water that is going to enter the cell because there's limited solute in the water. This is like sticking a cell in a fresh glass of water. Where's the water going to move? Well, it's going to move into the cell. The cell's going to go through and continue to expand until it ruptures. Now, lastly, in isotonic solution, there is no net movement of water across the membrane. We have an equal concentration of salt in the cell as there is outside the cell in the solution. So we call it an isotonic solution. So in this case, water is going to move equally across its membrane there because there's equal amounts of salt solution. Therefore, there's an equal exchange of water. So if we look at this example here, we can see this U with more salt on the left and less salt on the right. In the middle, this is a really common example we see in biology where we have a U with water, salt, and a selectively permeable membrane. And we're going to go through and we can see here, where is the water going to move towards? Where's the water going to move towards? Well, the water is always going to move to where there's more salt. So if we go through and we look at this, where's the water going to go? It's going to move to the left. It's going to move and change the actual water level located in that U. We can see that the water moves left, and since there's more water in that U to the left, we can see that the level is going to rise and it's going to equilibrate the salt to water ratio there when we go through and talk about osmosis. So it's important for us to understand this example because this is a common example that you'll see in biology. When you get to AP biology, you'll talk about osmotic pressure and reverse osmosis. Now, if we think about our vocab words in relationship to this U, let's compare side A versus side B in this scenario. Side A is going to be more hypertonic as compared to side B because there is more salt in that solution. Again, if you're hyperactive, you have lots of energy. If it's a hypertonic solution, there's lots of salt. We can see as compared to side B is going to be hypotonic in relationship to the hypertonic side on the left, A. But again, we want to use only one of these vocab words when going through and talking about these solutions. So that was a lot of content in that video. Let's go make sure we understand a few things. Do we understand the rule for osmosis and what osmosis is? Do we understand the three types of tonic solutions? So that is hypertonic, hypotonic, and isotonic. And then do we understand how water potential is going to affect the cell? Is the cell going to swell or shrink depending upon what solutions it's in, or is it going to remain the same? This is the end of the video. I will see you all in class tomorrow.